Uh, Name of this lecture is light. In details, we will be discussing about it. Standard is the 10th and my name is written over here. I want to discuss all those points which are important from this lecture. Our focus will be on discussion of light. This was the first slide in which you saw name of this lecture, introduction, my introduction. So now let's start with this slide. Here, light definition of light is written over here. Definition of light is written over here from the language of a book. Definition of light is it is a form of energy which helps us to see objects. Yes, it is a true. Without light, object cannot be seen. Our eyes will not be able to see any objects without light. If there is no presence of light, then anything we cannot see. We cannot see anything. In daily life, we are observing a lot of objects. We see a lot of objects. Even right now, you will be seeing a lot of objects that are surrounding you. It is possible because of there is a light which is coming and falling on the surface of the objects. That's why it became possible to see all things that will be in front of you. So in some word we can say any object. To see any objects we need light. Without light it is 100% impossible to see any kind of object. Second, when light falls on objects, it reflects the light, and when the reflected light reaches our eyes, then we see the object. This is a process. Second sentence is the process. How do we see? We know that when there would be facility of light, then we can see object. We know it. But okay, light is available in front of us. Then what is the process? What is the process of seeing objects with availability of light? So process is that source light will emit their light. Of course, source light will emit their light. Then those lights will be falling on surface. I am saying surface. Those lights will be falling on surface. Then it will turn into another direction. Remember, here object will matter. If object is opaque, then light will turn into another direction after hitting the surface. But here, if you take a transparent object, then what will happen? Then light will not travel into another direction. Rather than turning into another direction, light will pass through the object. If object is transparent, remember this is will happen. If you are shocked to see that light is not turning into another direction, it means object would be transparent. That's why it is happening. Okay, so anything we can see because of light falls on the surface of the object, then it turns into another direction. This is what is the process of seeing objects. Clear? Next is light travels in a straight line. It is a universal truth. Light will always travel in a straight line. It travels always in a straight line. It will be traveling in a straight line. Clear? You will never observe curved line of a light. Never. You will always observe a straight light of a light because it travels in a straight line. That's why. The common phenomena of light are formation. Remember, always remember. Here you can see light is in a straight. Light is going in a straight line. That's why this light which goes in particular direction looks in a straight line, which is actual, which is happening actually. Now next we have the common phenomena of light or formation of shadows. Yes, remember always we are studying physics as subject, and physics says that I will explain all those things which will be happening in a nature. And here shadow what is coming, which happens in our daily life. Right now I can see my shadow of myself. Right now I can see right now shadow of this book. I can see shadow of this hand. It happens. It is nature. Clear? But main point is that will all all objects form shadow? Answer is no. Shadow will be formed. It will depend on object. What is object? If object is opaque, then shadow will be formed by those opaque objects. But remember, if if object is transparent, then there is no possibility to form shadow behind that transparent object, because transparent object does not form shadow. Only opaque object forms shadow. Listen. Why does opaque object form shadow? Because of it blocks the light. Light does not pass through the opaque object. That's why any object which is blocking the light will form shadow. Understand? Understand? Even you are blocking the light, then shadow of your will appear behind behind it. Clear? Opaque opaque object will form shadow. It will happen. But when it will come to transparent object, then it will not transparent object will not form shadow anyhow, because transparent object does not block the light. It allows to pass the light which is coming from source light through them. That's why main word which is coming is that any object which will allow to pass the light will not form shadow. Any object which will block the light will form shadow. Will form shadow. Clear? Now next is the common phenomena of light are formation of shadow. Okay, till here we have seen, we have understood formation of images by mirrors and lenses, bending of light by a medium, twinkling of stars, formation of rainbow, etc. All about this we will understand one by one in each slide. One slide by one slide we will understand all about the bending of light by medium, about formation of images by mirrors and lens. All this will be covered in this lecture. We understood how does opaque object form shadow. Formation of images by mirror. I think right now we should not discuss about it. Now let's visualize this figure. Here you can see in this figure, here a light which is coming from torch. Torch is a source light. To form a shadow you should have two or three or four things. One, source light. Second, object. Third, observer. Fourth, a screen to observe shadow of object. Object should be opaque object. Now as we can see, all those things are in this figure. First is a torch, which is a source light. Second is a object, which is in front of a person, and person is a third object, which is observer. And behind a object there is a hole, which can be considered as a screen. Because shadow of object can be seen on wall if you don't have a screen. Here you can see easily light is coming from torch, and it is some lights are going in different direction, but some of those lights are going towards the objects that we want to see. All those lights are falling on the object, and then it will get reflected. These lights will turn into another direction, but after hitting the surface of the object, then it will turn into different direction. I will not say that all those lights, all those rays which could turn into different direction will fall on us. No. Some lights will take in this direction, some lights will take in this direction, some lights will take turn into in this direction. If we are here, then some lights will reach to your eyes, and this is way of reaching light after hitting the surface of the object, and that is how you observe objects. When light falls on the surface of the object, then it returns and reaches to your ears. This is what is a process. This is how you observe. You see a lot of objects. Now in front of this figure, there is one more figure. One is eye, second is a bulb, and third is a battery. What is happening? Electric cell is giving current to bulb. Bulb is small. This is not that bulb that we use in our home. This is not that bulb. It is used in toys. Yes, this is a that toy. Now, one wire here. How do we see lights? How do we get lights? This is a other question. From this figure, you can easily say we can we can observe light because of electricity is being provided to electrical device. That's why bulb is able to emit their own light. Bulb will be able to emit their own light when electricity will be provided to that bulb. To that bulb. Clear? Okay, now I am moving towards this slide. Here we have four figures. Let's visualize each figure. I will not ignore any slide, any figure, any sentence which will be mentioned in this lecture. First figure is showing reflection of light. About reflection of light. Again, you can see some rays of light are coming from source light, which is a torch, and surface is a here there is object where rays are falling, and object is above. There is a above object. That's why some lights took a turn into another direction. This is what is reflection of light. This is what is reflection of light. Here in first figure we can also understand about angle of incidence as well as about angle of reflection. Now you would say you are teaching us mathematics, but subject is physics. Most of you would be knowing that there is a math subject which is linked with this subject, with the physics subject. Without math, physics will be incomplete. It is said, and again I am repeating it because of I realized that yes, math will be important to include with this subject. It is already involved. Just I am saying that we cannot ignore math subject if you are afraid of mathematics, of studying mathematics. Then I am giving warning to you that just accept all those problems that you face in mathematics subject and solve all those problems. Here we were on the discussion of angle of incidence, angle of reflection. I can say directly that angle of reflection, angle of incidence should be equal to angle of reflection. This is the first law. This is the first law of reflection of light. But let's visualize it. We are talking about angle. It means we entered in mathematics subject. How much angle? And what are those two rays that are rotating. So two rays are, first is a normal line and second is a light, a beam of light which is coming from the source light is hitting the surface of the object. Till here, this is an incidence ray. Between normal line and incident ray, here we will form angle, and name of this angle will be called as angle of incidence. This was about angle of incidence. Here we are saying incidence. It means we will take incidence ray. Now you can understand that incidence ray is a ray which comes from a source light, will be striking on the surface. Till here it is a incidence ray. It is incidence ray. And now we take a normal line so that we can calculate angle. That's just we imagine that yes, there is a normal line. Between normal line and incidence ray will be angle, and name of this angle will be angle of incidence ray. Clear? You understood meaning of incidence ray. You saw how do those two lines will form a angle of incidence. This is what you understood right now. Now what about angle of reflection? Here some points are same, but something will be different. Again we will take normal line. One line you have taken. Now second line we will not consider as incidence because we have same incidence. Here we are talking about angle of reflection. This is what we are talking right now. Now here reflection. Just understand meaning of reflection ray. A ray which is a light. A ray of light which does not come from source light directly. It comes indirectly. A ray which is coming after striking the surface of the object will be a reflection ray. I'm not saying reflection angle, reflection ray. Now we will consider reflection ray as a one line, and second we have already, which is normal line. We have got two lines which is being rotated will be forming a angle. Now name of this angle will not be angle of incidence. Instead, name of this angle will be angle of reflection because of we took reflected ray. That's why when we will take incident ray, then that angle will be considered as angle of incidence. But you are taking reflected ray, then you are considering that angle as a angle of a reflection. Sometimes question can confuse you by giving a statement in which they will be mentioning that what is the angle of between surface of the object and incidence ray. You will answer something else, but here just try to understand. Is question asking what is the angle of incidence, what is the angle of between, what is the angle between incidence ray and normal line? No, this is what question is not asking. Question is asking what is the angle between surface of the object and incident ray. Where is the normal line? No, question didn't ask normal line. So here you will get confused and you will answer something else in the examination. Clear? So carefully try to answer. Now let's come to the main point. First law of a reflection of light says that angle, whatever is the angle of incidence, will be equal to angle of reflection. For example, angle of incidence is 35. So what does first law say? First law says that if angle of incidence is 35, then angle of reflection would be same 35. It is nature, it happens. Okay, that's why this is a law, first law of reflection of light. Now second law of reflection of light. We understood reflector ray, we understood incidence ray, normal line, refracted ray. All these points should be lying on a plane, on a surface. Surface can be rough, surface can be smooth, it doesn't matter. If a surface is rough, then you will not get image clear. If a surface is smooth, then of course you will get clear image, whatever you want. Now next we have a glass in second figure. In glass, water is full filled. From this figure, a figure in which there is a water, which is full filled of water. In this glass, there are two pipes. From this figure, you can understand, teacher will be teaching you about refraction, refraction of light. But right now we are not going into too much details about refraction of light. Let's understand about formation of a shadow from this figure. Easily you are able to see shadow of two pipes, not shadow of glass. Why? What's the difference between them? Difference between them is very simple. Pipes are opaque object. They are not able to allow the light which is coming. But here glass is a transparent object. And you know what is the meaning of a transparent object? Transparent object gives allow to come the light. Clear? Okay. So we were understanding about the shadow of these two pipes. But what is the reason behind it? Reason is very simple. Reason is very simple. Reason is that two pipes are opaque object. This is what is the reason. When it comes to opaque object, then you already know what is opaque. Here glass is not forming shadow because of glass is a transparent object. Clear? So you saw reason behind it. Now I was saying that angle of incidence, if this angle is making 35, then this will be also 35. We have understood this figure as well as this figure. Now in this figure you will see what a splitting of one color, a splitting of white color into 7 colors, and all those 7 colors are appearing here, and details will be discussed in separate slide. These are just examples of second slide in which we discussed something. Here in this figure you understood the reflection of light with angle of incidence and angle of reflection. In this figure you could have understood about reflection of light, but I didn't tell you because of it is not the time to understand about reflection of light. Instead, we can understand something else that is important for right for now, that is about the shadow, formation of a shadow by objects that we understood by this figure. And now in this figure we will understand a dispersion of light. As you know, white light has 7 colors. By using a device which will be transparent, can split the white light into 7 colors. If you want to see 7 colors of one light, of white light, then you will have to use a device, a object which will be transparent, and I will show you that object. Now here this triangle is being considered as a transparent object, and here this is a white light. This white light is falling on the surface of this object, and this object splits this white light into 7 colors, which are mentioned over here. This is what happens with the white color. Again I am telling you about it in too much details. We will cover it in separate lecture, in separate slide. Uh, about it more you will understand in lecture of a human eye and colorful world. Okay, so this slide is clear, is done for you. Now I am moving forward. A reflection of a light. Here we have understood a reflection of light. Let's see what is it saying, which is mentioned over here. When light falls on a highly polarized surface like a mirror, most of the light is sent back into the same medium. This process is called reflection of a light. Reflection of a light. We now, yes, how does a reflection of light happen? Laws of reflection of light. The angle of incidence is equal to the angle of reflection. It is telling you that angle of this incidence will be equal to angle of reflection, and this will be perpendicular. This will be considered as perpendicular line, and it is a horizontal. This is a vertical. This is horizontal. Horizontal line is making 180-degree angle, and vertical line is making 90. This side 90 and this side 90. 90 would be 180, which is the sum of two angles of making 180. So this is a straight line. This is a straight line which can be considered as a linear pair. I think so. You know what is the incident ray and what is a reflected ray. This first law is saying this angle will be equal to this angle, and second is saying this reflected, this incidence ray, this normal line and this reflected ray, all this will be on object. But remember, this surface of this object can be rough, can be smooth. If a surface of this object is rough, then you will not get clear image, you will get blur image. But surface of this object is smooth, then congratulations, you will be getting clear image. Now what is happening in this figure? In this figure, this is a normal line, this is a incident, and this is a reflected. Light is coming in this direction. It hit on this it hit on this surface. Then it turned into this direction, and this is a mirror. You know, behind this mirror is coated. Behind this mirror is painted by something, and that's why mirror is considered as a opaque object, because of it does not allow to pass the light through this, because of behind it is painted by silver paint. Okay, that's why. This is done. It is already done, but we were repeating it so that we can be clear. Now we have this. Let's see what is it. Here first is the image is erect. How type of image will be formed by plane mirror? This is what we are understanding in this slide. How type of image? First is the image would be erect. What is the meaning of this? Erect means as it. Size of your body would be equal to size of image which would be inside the mirror. So size of this is 5 inch, then size of this would be 5 inch. This is the meaning of erect. This is the meaning of erect. And shape of this would be same. Shape of this would be same as it is. Clear? This was about erect. The image would be erect if image is being followed by plane mirror. Next is the image is the same size as the object. Yes, we have same. Size of this would be same as size of this would be same as object has. The image is at the same distance from the mirror. The image at the same distance from the mirror as the object is in front of it. Here it is saying distance of this object from here till the mirror is 4 cm. Then same from the mirror till the image would be same. This kind of image you will be getting. So size would be same, shape would be same, distance as well, it would be same. The image is virtual, cannot be obtained on a screen. It means we just imagine that yes, there is an image of object image that we see, duplicate image that we see inside the mirror is not original. That's why this type of image will be considered as a virtual. Image which would be inside the mirror will be virtual. Virtual, which means image which cannot be obtained on a screen. The image is laterally inverted. What is the meaning of this? Is laterally inverted, which means right hand of the person will appear in left side inside the mirror, and left hand of the original person will appear in the right side of the image. This is what is the meaning of laterally inverted. One more point I would like to add here in the discussion of laterally inverted is that any words, any letters you put in front of a mirror in a correct manner, you will realize that all these words are in stranger inside the mirror. This is also meaning of laterally inverted. Okay. Now this first figure, what is it saying? Let's see. Here is an eye. A person is observing. This eye is here. Light is coming from here. This candle, light is coming from here. And it is a mirror. Let's say it is a mirror. This light is coming like this. It will be reaching to our eyes. This is what is happening. This is what is happening. Direction of light. Just observe carefully the direction of light. Light is coming from this. Of course, our eye cannot emit the light because it does not have light. That's why. Candle has a light which is emitting. It is coming like this and striking on the surface of the mirror. Then some rays are reaching to our eyes. Now it is telling you that distance of this from this would be same here, and the size of this would be as it inside this mirror. This is what we saw here. Clear? So here you can see it is focusing on the distance of the original object and uh, duplicate image. We have visualized this as well. Here this is your original hand, and inside the mirror is a duplicate image. Original hand will be considered as object, and duplicate image which is inside a mirror, whatever object is appearing inside the mirror will be considered as image. Remember, will be considered as image. In details about it, I will discuss more in upcoming slide. For now, it will be sufficient for you. Next, spherical mirrors. Do you know how did we get two types of mirror? First is the concave, second is the convex. How did we get? Answer would be, we got these mirrors from spherical mirrors. These two mirrors was cut from spherical mirrors. This is first part and this is second part. When we will add these two parts together, then it will form a spherical mirror. Let's see what is a spherical mirror. A spherical mirror is a curved mirror. It is a curved, yes. We have talked about plane mirror. Now we are going to enter in the discussion of spherical mirrors. From the spherical mirrors, we will take two types of mirrors. First is a concave mirror, second is a convex mirror. All these two mirrors will be curved mirror, will not be plane mirror. Okay, curved mirror, which is a part of a hollow sphere. It is not exact. It will not be exact circle. Instead, it will look like a hollow sphere. Otherwise, you can say a spherical shape. Spherical mirrors are of two types. Spherical mirrors can be cut into two parts. First would be concave and second would be convex. Rays of light parallel to the principal axis after reflection from a concave mirror meet at a point converging on the principal axis. This was about concave mirror. Here, I think it would be concave mirror. Remember, you will have to remember that which one mirror is concave, which one is not concave, which one is convex. So this is what you will have to understand just by using the something here. Concave, which means inward, cave which means inward, and vex which means outward. So inward would be reflecting surface and outward inward. Concave mirror will have inward part which will be reflecting part. and convex mirror. This is a convex mirror. So outward part, outward surface will be reflecting surface. Outward surface will be reflecting surface. Remember, concave mirror is a spherical mirror whose reflecting surface is a curved inwards. You can see this is a curved inwards and it is a reflecting surface. We will not say that this outward surface will be reflecting. No, this curved is a reflecting surface will be considered this mirror will be considered as a concave mirror because its inward surface is a reflecting surface. That's why we are considering this a mirror as a concave mirror. Now, rays of light parallel to the principal axis. This is a principal axis, and these are parallel rays. After reflection from a concave mirror meet at a point on the principal axis here. This parallel lines, always remember, this parallel lines will meet after the reflection will meet here on the focus, on the principal axis, exact on the focus. Now what about convex mirror? It is also a spherical mirror. It is a part of a spherical mirror whose reflecting surface would be outward, because we are talking about convex. So of course outward surface would be reflecting surface. Rays of light parallel to the principal axis after reflection from a convex mirror get diverged. Here we were observing what all these parallel lines are converging at F. But in this figure, what will you realize that all parallel lines will be diverged rather than converging. It will happen with the convex mirror. If rays of light are coming parallel to the principal, then all those parallel lines will diverge into different directions. It happens with the convex mirror. Rays of light parallel to the principal axis, okay, mirror get diverged and appear to come from a point behind the mirror. Here we are not talking about principal axis, focus, pole, what else, radius. Yes, we didn't talk, but it doesn't mean that we will not talk. We will talk. I am make sure that we will understand about principal axis, about pole of the mirror, focus, radius. All about this we will understand. In this, you just need to understand that yes, a mirror which surfaces inward will be reflecting surface. This is what we need to understand in this slide. From this slide you can also understand more things, but my simple concept is that gradually we will be understanding all those points, all those words which will give knowledge to us. Clear? So I think it will be enough in this slide. Now shall we move? According to me, we should move. In next slide, let's see what is there. Here, as you can see, we came on the main topic that we wanted to discuss. I promise you, and I fulfill that promise. Here, term used in the study of a spherical mirrors. First is center of curvature. Center of curvature. Center of curvature is the center of the sphere of which the mirror is a part. The mirror is a part. Center. Here remember we are talking about center. We are talking about center. Here this is a mirror, and where is the center? Here, not here. We are talking about center of the spherical. If this is a concave, then we know that this is a part of a spherical. That's why we will take a center here, and from here to till here it will be curvature of the center. It is the center of the sphere, okay, not a concave mirror, of which mirror is a part. So we will represent the center of a curvature as a C. Now next is, so what is the center of a curvature? It is a center of the spherical mirror. Remember, of the spherical mirror, not of the uh, concave mirror or convex mirror. No, we took concave mirror, convex mirror from this spherical mirror. That's why we will be considering a center of a curvature from the spherical mirror. It is the center of the sphere of which the mirror is a part. Next is the radius of a curvature. Yes, you will have a radius on the curvature. Radius of the curvature is the radius of the sphere of which the mirror is a part. Radius. Here on this line, which is between, on this line a radius will appear. Right now radius is not mentioned over here, but I am saying you radius will be mentioned over this line in upcoming slide. So radius is nothing but it is a, okay, in details I will tell you. Next is a pole. Pole is the center of the spherical mirror. It is a spherical mirror. Now next we have principal focus. It is also important. What is the principle of focus? It is in a concave mirror, rays of light parallel to the principal axis. After, okay, let me clear you. Remember, this is a pole. It is already mentioned, which is a focus, and center of the spherical mirror will be considered as center of a curvature. Remember, this is pole, this is focus, this will be curvature, center of a curvature. What else? This whole line from the center till the pole, from the center of a curvature till the pole will be principal axis. Remember, will be principal axis. So in a rays of light parallel to the principal axis after reflection meet at a point on the spherical axis called principal focus. Here you can easily see a parallel of lights which is coming from a source light is falling on the surface of the concave mirror. It is meeting over here. This is a focus. This is a focus of a curvature center. In a convex mirror, rays of light parallel to the principal axis after reflection get diverge and appear to come from a point on the principal axis behind the mirror called principal axis. Now let's see what is it. Principal focus. Here this parallel lines are falling on this surface are turning into another direction. This is happening. It is not converging, instead it is a diverging, because it happens with a convex mirror. Here focus will be here. Here remember, object will be here over here. It means object is a real. It can be obtained on a screen, but here rays are not meeting. Rays are going this direction. Rays are not meeting at a focus. That's why we will imagine here. We will drag this to imagine that it is passing the focus, and here image will be formed, which will be imagination, which will be inside the mirror. This is how you get real image. This is how you get a duplicate image. Next we have focus length is the distance between the pole and principal focus. In a spherical mirror, the radius of a curvature is twice the focal length. R is equal to 2f. It means R is 2. It is telling you if this is f, then this here it would be R. Just trace of the focus. Now next we have a simple figure. Through this figure we can understand about x, c, f, p, and next is a y. Now here C is the center of a curvature. C is the center of a curvature, as we saw that it is here, over here. It is the center of the spherical mirror. I am not talking about this point. No, it is a pole. It is a pole. We will consider it as a pole. Center of the curvature is the center of the spherical mirror. Next is a pole. This is a pole. A point which is a center at the reflecting surface. So center would be here at the reflecting surface. Next is a principal focus. Principal focus. Okay. Is the distance between the pole and principal axis. In a spherical mirror, for the radius of a curvature is a twist the focal length. It is telling you principal axis. This principal focus is just a half, and a twist of this would form a R. Twist of this would form R here, over here, R. R is formed by taking two. Next is a CP. From here to till here, it is a radius of a curvature. Wow! from here to till here. I was thinking that I thought that from here to till here it is a principal axis, but now it is telling you it is a radius of curvature. Next is xy. Xy, which means principal axis. Where is x? This is x and this is y. Now we are right. From here to till here, it is a radius of a curvature. Radius of curvature. But from x till the y will be considered as a principal axis. Next is a focal length. Next is a focal length. Reflection by a spherical mirrors. In a concave mirror, a ray of a light parallel to the principal axis after reflection passes through the focus. Yes. In a concave mirror, you will realize that parallel rays of a line will be converging, will be meeting at one place, but not inside the mirror. This is what happens with the concave mirror. In a convex mirror, a ray of light parallel to the principal axis after media appears to diverge from the focus. From the focus. Here, as you can see, this is a parallel, and it is we are considering this as a